Welcome to the class of pH metry. Myself, Dr. Bhavna Mukesh Vyas from Pune Institute of Computer Technology will be taking today the pH metry session. So first of all, let us see what are the objective and learning outcome. Objective is to understand one of the electroanalytical technique which is called as pH metry, and once we know this, the learning outcome for the students will be they will be able to understand the selection of appropriate analytical technique by means of which they can analyze the different materials or the systems. So first of all, let us see what is pH. So this everyone knows that pH represent hydrogen ion concentration. But as far as definition is concerned, we define it as a negative logarithm of hydrogen ion concentration. And as we know, its pH is in terms of equation, we write pH is equal to minus log of H ions, where H ion is the concentration of hydrogen ion in moles per liter. And if we see the applications of pH, then the pH measurements are mandatory for different types of industries like food industry, paper and pulp industry, paste industry, agriculture industry, even in the water treatment it is required. And not only in industries, it is also used in the laboratories wherein the pH of a solution is required to maintain. Now, let us take the pH of some real systems. The pH of lemon tea or lemon juice is little bit is acidic in nature, more acidic in nature as compared to milk, and milk is more acidic as compared to the drop of blood. So you may be knowing the pH of a blood drop, what it is? Yes, any guess? It is more than 7. And even the ocean, if we go for checking the pH of water, ocean water, it's a brine solution, it is more alkaline in nature. And highly alkaline solution, if we go, then the pH of highly alkaline solution, for example of strong base or strong alkali like NaOH, sodium hydroxide, will show the value of pH 14. So this is the Sorensen scale, or also called as pH scale, wherein the value is increasing on this side, or when we say when it goes from neutral to acidic, the value decreases. From neutral to alkaline or basic, the value increases. The value of pH increases. And here on the right side, these are the different samples. Here we can see that the human blood sample is the pH of human blood sample is 7.35 to 7.45. So it is little bit alkaline in nature, little bit, not highly alkaline. Okay. And regarding the pH of seawater, here it's mentioned it's 8.1, but it can vary. This is the average global surface ocean pH is measured. Okay. So once we know this, let us see the pH metry and how it is useful in the. So first, the question I'll ask is, what is pH metry? Of course, it's an electroanalytical technique in which pH of a solution is measured using pH meter. Where it is used? pH metry is an important application of potentiometry for the determination of pH. So it is used to find out the equivalence point of strong acid, strong base titration, or various types of acid base titration wherein we do not use any indicator. Okay, so let's say if we want to use it for strong acid, strong base, then in that case, strong acid as well as strong base, both are colorless. And when we mix this, the solution, whatever is getting formed, is also colorless. So without use of any indicator, it is impossible to get the equivalence point. So pH metry, which is an electroanalytical technique, gives us the equivalence point. So one can measure the equivalence point of that acid base titration. So let us consider one example wherein we'll keep our objective as to determine the unknown concentration of strong acid using pH metry. Okay, so consider example as HCl and NaOH, because HCl is a strong acid and NaOH is a strong base, and since they are strong acid and strong base, both will get dissociated completely. So we'll call it as a SASB titration, that is strong acid strong base titration, wherein we'll take a strong acid in a conical flask or in a beaker for the analysis, since we want to know the unknown concentration of strong acid of that acid. So the reaction which will take place during the pH metric titration is HCl plus NaOH will give you NaCl and water. So NaCl salt will get formed with water. So this is also called as neutralization reaction, right? So now let's see what things will be required during this. Obviously, the very first thing that will be required is the pH meter. And now in the previous video we have seen the working of this pH meter. This pH meter is having electrodes which specifically the indicator electrode which is used is a glass electrode, wherein it is capable of measuring the H-ion concentration of the solution wherever it is dipped. So a pH meter having that indicator electrode, that is glass electrode, we will require during this titration of strong acid strong base. And so let us go with the procedure that how we get that. So first is we have to calibrate the pH meter. That is, it means we have to standardize the pH meter before we use it for a particular application. So how to calibrate that also I have told you in the previous video, that pH meter is standardized by using standard buffer solution of known pH of 4, 7 and 9. Okay, then since it's a titration, we have to take a known quantity of HCl in a beaker. Suppose V1 ml of HCl we have taken in a beaker, and in that beaker we have to keep the magnetic needle for stirring part, and then that beaker is kept on a magnetic stirrer. Then we have to carefully immerse the indicator electrode and the reference electrode in that beaker. So and then start the here the reference electrode is calomel electrode, which I have already told you in the principle in the previous video. So once we do that, once we immerse the electrodes in the beaker, we have to start the magnetic stirrer. And once we start the magnetic stirrer, what we have to do is we have to note down the pH of the pure acid solution, which will get displayed on the pH meter. So this is one thing, and another is we have to fill the burette with 0.1 normal of NaOH. So here we can say that we are filling the burette with known normality of NaOH solution, and then we add that n by 10 NaOH or known normality NaOH solution slowly. Let's say add by 0.5 ml to the acid in the beaker. And so once we do that, we have to continue that addition of NaOH from the burette and note down the corresponding pH after each addition. So near the equivalence point, the change in pH is much more rapid than in any other region. So stop the addition when the pH value remains nearly constant. So what we have to do is we have to note down all corresponding pH for different volumes of base added in the beaker. And since there is a magnetic stirrer inside the beaker, the reaction mixture will get stirred properly. So the value of pH, whatever are getting displayed, will be accurate one. Okay. So what will be our observations? Obviously, the very first observation that we'll say is the initial volume of acid taken, which is V1 ml, the volume of strong base added for, let's say, from 0 ml, then 0.5 ml, 1 ml, 1.5 ml, 2 ml, like that, and corresponding pH value, right? pH of the solution of the reaction mixture. And in calculation part, since we want to know the unknown concentration, we want to calculate the unknown concentration, we have to plot a pH metric titration curve. So a pH metric titration curve is a plot of pH versus volume of strong base added. So pH will be on y-axis and volume of strong base added in ml will be on x-axis. So let's see how the pH varies when we add the volume, when we add the strong base in that strong acid. So initially the pH will be very low because it's a strong acid. So the value of pH, of course, it will be less. So, but as you go on increasing the addition of strong base, what will happen is the pH will increase slowly. It will increase slowly, but when it reaches near to the equivalence point, then what happens? It shows an inflection. A rapid change in the pH value can be seen near to the equivalence point. And then after the equivalence point, we can see that it again increases very slowly. So almost constant, that we can say. So after equivalence point, the pH value increases very slowly. So this is the pH metric titration curve specifically for strong acid, strong base titration. So here what we can see is the inflection near the equivalence point. So just a one inflection is seen for strong acid, strong base, since it's a single strong acid is getting added to the single strong base. Suppose if it would have been a mixture of weak acid and strong acid, then we can see the two inflection, one for strong acid, another one for strong acid. So one is for strong acid, other one for weak acid. So we can see the two inflection if it would have been a mixture. But in case of strong acid, strong base, only one inflection is seen. So even I can say that if I see that graph or if I see that curve, it's a S-shaped curve for the SASB titration. So this is a pH metric titration curve for strong acid, strong base. Now what we do, what is the use of plotting this? So basically what we after plotting this pH metric titration curve, we see that at value of pH 7, so what we do is we take a scale and we just draw a line from pH equal to 7, and which will cross this value with the data points, and then just drop down from this. So drop down a line from this which is parallel to y-axis, so that it will cut somewhere here at x-axis. So that is a volume of base at equivalence point. So at pH equal to 7, the volume of base, whatever we'll get, will be the volume of base at equivalence point. And because at equivalence point, the value of pH is equal to 7, because equal amount of H ions and OH ions will combine to form water. Okay. So once we get that, we'll note down the value of base at equivalence point, and then using equivalence equation, that is N1V1 equal to N2V2, we can calculate the normality of acid. And so once we get the normality of acid, the strength is then further can be calculated by using this formula. Strength of acid is equal to 36.5, which is the equivalent weight of the acid into normality of acid, which we have calculated from this equivalence equation, and the volume of base at equivalence point, which we have obtained from the pH metric titration curve, divided by volume of acid taken. Okay, so this is what about the the objective of this pH metry. What was the objective we have started with? We have started with the objective of knowing the strength of the acid, or knowing or calculating the unknown concentration of acid using pH metry. So in this way one can obtain the strength of acid using pH metry. So now test yourself, tick mark the right answer. So if it is only single answer, just tick it once. If it is more than that, then tick it accordingly. So the first question is pH is defined as, so as per your learning, tick mark the right answer. Then second one is strong acid, strong base pH metric titration curve. The value of pH shows inflection at pH metry is which type of technique or analysis. And these are few subjective questions that you can go through, and this is for this topic, pH metry. So I'll stop here. Thank you. See you in the next video. Thank you.